ever catch yourself like, I don't know, kind of daydreaming about AI being, smart enough to do its own research? It's like, imagine if you could just tell an AI, hey, go figure out this problem. And it doesn't just analyze the data, it actually designs the experiments, writes the research paper, maybe even presents it at a conference.
Yeah.
Kind of wild to think about, right?
It is pretty wild when you say it like that, yeah.
Well, that's actually what we're kind of diving into today with this open AI thing, this MLE-bench.
Yeah, MLE-bench. It's a bit of a mouthful.
It is.
It stands for Machine Learning Engineering Benchmark. And it's basically like they're trying to see if AI can actually be a machine learning engineer.
Whoa. Okay. So, like, are we talking about replacing scientists with robots here?
Well, not quite replacing, but it's definitely getting close.
Okay. So how do you even test that? Do they give these AIs, like, I don't know, pop quizzes on algorithms?
It's a little more intense than a pop quiz. They actually threw them into the arena of Kaggle competitions.
Oh, wow. Okay. For our listeners who may not know, what's a Kaggle competition?
So Kaggle competitions, they're these like data science death matches, kind of. They're super intense. And they're all about like who can build the absolute best algorithm to solve a particular problem, whether it's like predicting customer churn or, identifying diseases from medical images. It gets really complex.
Wow. Okay, so this is not just like textbook stuff. We're talking about real world challenging problems that people are like actually trying to solve.
Exactly.
And we're throwing AI into that mix.
Yeah, and these are not your average AI either. We're talking about large language models.
LLMs.
Oh, LMs, exactly.
Yeah.
The big kahuna, like GPT-4, the one everyone and their grandma's talking about these days.
Right.
And OpenAI's own kind of like, O1 preview model.
Yeah.
But here's the thing. They didn't just like unleash the LMs on the data and say, go wild. They gave them a little something called scaffolds.
Scaffolds? Is that like giving the AI like a cheat sheet or something?
Not exactly. Imagine it more like giving the AI a set of tools, right? It's not doing the thinking for the AI, but it's kind of like giving it a structure to work within. Like think of it like this. If you're building a house, you don't just start throwing bricks together, right?
Yeah.
You have a blueprint. You have scaffolding to help guide the process.
Right. To like support the structure.
Exactly, yes. Support the structure while it's being built. And that's what these scaffolds are doing for the AI.
Interesting. So they're not being told exactly what to do, but they're being given a framework to like think within.
Precisely.
Okay. Interesting. So how did they do? Did these AI ace the test? Did they win any of these Kaggle competitions?
Well, no Nobel Prizes just yet.
Yeah.
But the results were definitely intriguing, to say the least.
Okay.
So the best AI agent, fully equipped with its fancy scaffold, it actually managed to score at least a bronze medal in about 17% of the competitions.
17%, huh?
Yeah.
That's not good.
17% might not sound like a lot, right?
Yeah.
But remember, these are Kaggle competitions, so we're talking about going up against some seriously talented, experienced data scientists, people who do this for a living,
Oh, wow, yeah. These are the pros.
These are the pros.
So to even get a bronze medal?
Exactly. It's a big deal. To even be in the running is impressive.
Okay. That's pretty wild. So, what does that actually look like? What were these AIs doing? Were they just, crunching numbers faster than humans or something?
It's way more than just number crunching, actually. One of the really fascinating things about MLE-bench is that they didn't just test these AI agents on, one specific task or type of data. They threw a whole bunch of different Kaggle competitions at them.
Like what? Give me an example.
So we're talking developing algorithms to predict the properties of new molecules, or analyzing medical images for signs of disease. There was even one where they had the AI trying to translate ancient languages from scanned texts.
Wait, hold on. AI translating ancient languages? That sounds like something straight out of an Indiana Jones movie.
Right.
That's wild.
It's incredible. And while we're not quite at the point where we've got AI archaeologists, rewriting history books, the fact that they can even attempt something like that just shows you how adaptable these systems are becoming.
That is pretty incredible. It's kind of like they're learning to think across different domains and apply their knowledge to all sorts of different problems.
Exactly. And that's a big deal.
Okay. So we've got AI that's learning to think, researchers, they're competing in these high-level competitions. I mean, should scientists be worried? Are we all about to be replaced by robots?
That's the million-dollar question, isn't it? I mean, it's definitely something people are thinking about, and for good reason. But based on what we've seen from MLE-bench, it doesn't seem like we need to hand over our lab coats to our robot overlords just yet.
Okay, good. Good to know.
There are still some things that are very much human about the research process that AI hasn't quite figured out yet.
Oh, really? Like what? Give me the dirt.
Well, one of the key things they found was that these AI agents, as impressive as they weren't always the best at, like, managing their own time and resources. Like, they might know how to run a complex analysis, but they might not know when to, like, switch gears if something's not working or how to prioritize different tasks. They haven't quite mastered that whole strategic thinking thing.
So it's kind of like they have all the tools, right? They just don't know how to use them effectively. Like, is that what we're saying?
Yeah, it's a bit like that. It's like they got this incredible toolbox, all the latest and greatest gadgets, but they might not know which wrench to use for which bolt, you know?
Right, right. Or like they're trying to use a hammer to put in a screw. It's not going to work.
Exactly. And that's where human researchers, we still have that edge. We can look at a problem and we can kind of intuitively know, like, okay, this approach is a dead end. Time to try something else. Or, this is where I should be focusing my energy right now.
That makes sense. Because even in like regular research, you're constantly having to make those judgment calls, right? Like, do I keep going down this rabbit hole or is it time to like completely rethink my approach?
Totally. It's all about resource management.
Yeah.
You've got limited time, limited funding. You got to be smart about where you invest your energy.
Exactly. And it sounds like that's something AI hasn't quite wrapped its algorithms around yet.
Yeah, not quite. And honestly, who knows if they ever will? I mean, there's something about those like intuitive leaps, those aha moments that lead to breakthroughs that, well, it's hard to imagine how you would even begin to program that into a machine.
Yeah, like how do you teach a computer to have an aha moment? That's pretty wild.
Yeah. It is pretty wild. And it brings up this whole other question, like, what does it even mean for an AI to have an aha moment? Are we talking about genuine understanding, or is it just really, really good pattern recognition?
Right. Is it actually understanding the problem, or is it just seeing a pattern that it's been trained to recognize? That's a deep philosophical question.
Deep, man. And honestly, I don't think we have the answer yet. I mean, philosophers and computer scientists have been debating this stuff for decades. Right. And it seems like the more we learn, the more questions we have.
It's true. The more you learn, the less you know. But okay, we're talking about these AI agents, these LLMs, and how impressive they are. But like, how do we know they're not cheating? Because I mean, these Kaggle competitions, they've been around for a while, right?
Yeah.
What's to stop someone from just like feeding the AI a bunch of solutions from past competitions?
You've hit on a really important point. They call it the contamination problem. The idea that the AI might have been exposed to information that would give it an unfair advantage. And the OpenAI researchers, they were very aware of this. They didn't just want to create an AI that could parrot back solutions that it had already seen, They wanted to see if it could actually generalize its knowledge and come up with new, original solutions. So they took a couple of steps to address this.
Oh, like what?
Well, for one thing, they used this really cool tool that's kind of like a plagiarism checker, but for code.
Oh, wow.
You can scan through the AI's output and see if it matches any existing code from, like GitHub or other public repositories.
So it's like making sure the AI isn't just copying its homework from the internet.
Exactly. They wanted to be sure that what they were seeing was genuinely new code, something the AI had come up with on its own. But they didn't stop there. They also did this other thing, which I thought was really clever. They intentionally obfuscated the descriptions of some of the Kaggle competitions.
Obfuscated? Meaning?
Meaning they changed the wording. They removed any obvious keywords or phrases that might tip off the AI that it had seen a similar problem before.
Oh, sneaky. So it's like they're giving it the same basic problem, but dressed up in a different outfit to see if the AI can still recognize it?
Exactly. Mm-hmm. Because, like, you can teach a kid how to solve for X, but can they solve for the unknown quantity represented by the symbol? It's testing their actual understanding, not just their ability to memorize.
Right, right. It's like you can teach someone to follow a recipe, but can they actually cook? So what happened? Did the AI like freak out when it saw these obfuscated problems? Did it just crash and burn?
Surprisingly, no.
Yeah.
Even with the obfuscation, the AI still performed really well. Not quite as well as it did on the non-obfuscated problems, but still way better than you would expect if it was just relying on rote memorization. And to me, that's actually the most exciting part of all of this.
So even when they tried to like throw it off the scent, the AI could still kind of sniff out the solution, which is, I gotta say, it's impressive, but also kind of like low-key terrifying, right? It's like, okay, you're not cheating, you're actually learning. And that's kind of scary, but okay, let's bring this back down to earth for a second. we've talked about what these AIs can do, but like, what does it all actually mean for like, the average person listening to this? Should we be excited? Should we be scared? I mean, what are we looking at here?
Well, it's a bit of a choose your own adventure at this point, isn't it?
Yeah.
But honestly, I think there's a lot to be excited about. Because imagine a world where AI isn't replacing researchers, but it's actually like supercharging them.
Okay.
It's like having like an army of super-powered research assistants who can handle all the tedious stuff, the data cleaning, the code debugging, all that, grunt work. And that frees up the human experts to do what they do best, which is like the big picture thinking, the creative problem solving, asking those really like, out there questions that lead to those big breakthroughs.
So instead of worrying about robots taking our jobs, we should be thinking about how to use them to make our jobs better.
Exactly.
Okay, I like that.
It's all about collaboration,
Yeah.
Like imagine medical researchers being able to develop life-saving treatments way faster, or climate scientists modeling climate change scenarios with like way more accuracy, all because they've got AI helping them out with the heavy lifting. Yeah. That's a future I can get behind.
Yeah, that's a future I can get behind too. And it sounds like it might be closer than we think, right? I mean, if this MLE-bench is anything to go by, AI is already like knocking at the door of serious scientific research.
Oh yeah, it's knocking, and it's getting ready to kick that door down for sure. We're talking about a complete paradigm shift in how we do science. It's an incredibly exciting time to be alive, to be like witnessing this technological revolution unfolding right in front of us.
Yeah, for sure. And even though, there's always going to be those concerns about new technology, the potential here is just, I don't know, it's too big to ignore.
Absolutely. The potential benefits are enormous. I mean, who knows what we might discover, what problems we might solve when we've got AI helping us along the way. The whole new world of possibilities.
This has been a really, thought-provoking conversation. And I hope our listeners are just as mind-blown by this as we are.
Yeah.
Because this is really just the beginning, like where this all goes from here. It's anyone's guess, really.
And that's what's so exciting about it. We're writing the next chapter of scientific discovery as we speak. And AI is going to be a major character in that story. No doubt about it.
So before we wrap things up, I want to leave you, our listeners, with this one thought. We've been talking about AI getting to bronze medal level research, but what happens when it's going for gold? What happens when it starts making discoveries that we, with our puny human brains, couldn't even dream of? That's the future we're facing, and it's a future full of, I think, incredible potential. And it's a future we'll be here to explore, right here on The Deep Dive. Thanks for listening, everybody.
Thanks for having me.